From the Dome to Paris, this is NVIDIA GTC Live at VivaTech Paris 2025.
Over the next 3 days, hundreds of thousands of attendees will gather at Europe's largest startup and tech event, a global stage for what's next in the industry.
Taking the stage this morning to deliver the can't-miss keynote address is NVIDIA founder and CEO, Jensen Huang.
But first, we brought together industry leaders from across Europe to explore how accelerated computing and AI are reshaping the continent and the role NVIDIA is playing in that transformation. The City of Light is our stage, and we're just getting started.
This is NVIDIA GTC Live at VivaTech Paris 2025. Let's go. Bonjour from Paris. I'm CJ Muse.
And I'm Nick Patience.
And welcome to NVIDIA GTC Live. Look how incredible this is, Nick. We're outside the Dome de Paris, and people have been queuing up for hours, and we are on day one of this conference. But we know they're really here to see Jensen's keynote, which is now less than 2 hours away.
Yeah, I'm so excited to be here. I'm a technology industry analyst, and I've been following the AI space for 25 years. And in that time, GTC has become the go-to AI event in the calendar. It's great to see Jensen in Europe. He was in London on Monday, and we're here in Paris on Wednesday, and we know he's going to other European countries from here. It all just reinforces the importance that he and NVIDIA attach to the AI market in Europe.
It's also great for me to be here, this time as a co-host of the GTC Pregame. I'm a financial analyst covering the semiconductor space for 25 years, and seeing Jensen never gets old. It's still just as exciting to see him as day one. I was a guest at the GTC Pregame in San Jose, but obviously a lot has changed since March. We are very excited to be here at VivaTech, the largest technology event in Europe, to discuss the ever-changing tech world.
Europe's supercomputing ambitions, fueled by NVIDIA technology, are driving breakthroughs in climate modeling, in genomics, and the AI revolution. For our first chapter today, we'll trace the journey from early university and lab alliances through the dawn of petascale computing and energy-efficient innovation to today's exascale era.
Together, we'll unpack how GPU-powered systems are not only breaking speed records, but also shaping Europe's data economy and scientific future.
Today, we're announcing the addition of 20 new CUDA research centers across the globe. Europe has always been rich in AI expertise.
We heard Jensen in the UK on Monday explain the need to build out the AI infrastructure. With us today are three incredible guests to discuss that in the context of the wider European tech universe. Please welcome Dr. Thomas Lippert, the director of the Huang Supercomputing Center and professor of modular supercomputing and quantum computing at Goethe University Frankfurt. Thomas, welcome. We also have Dr. Loïc, Henriet, CEO of Pascal, which leads the development of neutral atom quantum processors for industrial applications. Welcome.
Hello.
And finally, Professor Mateo Valero, founder and director of Barcelona Supercomputing Center. Welcome. It's great to have all of you here.
Welcome, everybody. So just ask the first question, really, maybe to Thomas first and then Mateo about supercomputing. So NVIDIA talks about the modern supercomputer as an AI factory. Driven by the metrics of tokens per watt per dollar. So how is this focus on AI efficiency changing the definition of high-performance computing and maybe reshaping your business models? Thomas?
So AI efficiency is, of course, now the most important activity that we pursue in supercomputing. But we do not forget, of course, our provenience, where we come from, supercomputing and simulation. It's important to understand that simulation and AI come together. So we need two metrics. We need a simulation matrix, but we need also AI efficiency matrix. If we talk about a supercomputer, there is a big difference between both. Yeah. So take, for instance, the Jülich supercomputer Jupiter, where you have the goal to achieve 1 exaflop simulation performance in 64-bit, but up to 40 or even 80 in sparse mode AI performance.
Mateo?
So from my side, I would say that there are not supercomputing center anymore. There are AI center. In some of them, we have very fast supercomputers, and we can do things that cannot be done in other places. Since many years ago, we are trying to classify supercomputer because we are expert on that, okay? Let me tell you that the most classical metric we use, for me, has no value. And everybody asks you, where is your computer in the list? The third is good. No, it doesn't mean that, okay? Because the test is very simple, and the supercomputer don't do that. Normally, application related to this test, and we have many of them. But obviously, as we are changing, as Professor Thomas Lippert, we are changing the kind of application, we need to look for metrics related to the AI. So the one proposed to me could be one of them. We can identify many others, but that could be one of them added to the list of classifying supercomputer.
Loïc, I'd like to focus on quantum computing. So first, what is it? How is it different from high-performance computing? And there are so many different approaches. Will we evolve to one or two best approaches? What do you think?
Yeah, well, quantum computers or quantum processing units are a novel kind of hardware. To actually run complex workflows, you use CPUs, GPUs, but you can also use QPUs, quantum processing units. The thing about quantum computer is that they work with different physical paradigm at the very low level. So instead of having classical physics, like in gates between zeros and ones, you have like quantum physics that you can play with and that you can harness for computation. So it means that you have a different kind of logic, so new operations and new algorithms that you can deploy on quantum processing units. And really, it's not a replacement of classical technology at all. It is really complementary with the other compute modalities, other hardware, CPUs and GPUs. QPUs, they can do specific things, very good, but for other things, you'd better use a classical computer for that. It's far too complex. And yes, for the moment, there are various types of quantum computers. You can use atoms, photons, engineered circuits. Each modality has its own advantages, let's say, and for the moment, they are all coexisting. And I think they will continue to coexist for some time. We still have like many classical types of processors. And in terms of quantum processors, it will still be the same for at least 5 years, in my opinion.
Just staying with roughly the same theme, so the relationship between quantum and AI specifically, and I'm just curious what you think, maybe starting with you, Thomas, and also, can quantum accelerate the path towards AGI, if AGI is a good thing to be having a path towards?
So let's first talk about AI. Yeah?
Okay.
So for sure, quantum technology promises to speed up AI computations in a diversity of directions. There's a simple one where you can do the optimization step in an AI training computation supported by a quantum computer. So the quantum computer allows you to do some optimization better or in a different manner, and so with different characteristics than you would do it with a classical computer. But there is also the more interesting prospect that you can directly conceive a quantum circuit that is an AI system. Yeah? And people are now starting in this direction. It's promising, it's very difficult, and we hope that this will end up also in some improvement. If you talk about AGI, that's a difficult question of a definition of an AGI.
Keeps shifting, doesn't it? Yeah.
Different philosophies behind. As a more technically oriented person, and a little bit experienced in brain research, I was member of the Human Brain Project, I have the feeling that we should not overdo it at this moment. Let's continue with AI and see what happens.
Fair enough. Mateo, do you want to?
I think that clearly the AI held the classical simulation. This is clear, okay? So obviously, if the quantum computing can help AI and the classical supercomputer, that would be great. But I am not very happy with the result coming from the quantum computing for the moment. They are promising many things. They are doing real work, but I don't know if you can predict when the question that has been given to us.
Maybe you're not working with the right provider then.
No, we are working. I mean, I think you are in the winter, in the polar winter, in general. Okay, you are doing very big advancement, but I don't know when. And the question is for you: when are you going to do real work? Because at the end, the supercomputers are going to be heterogeneous. Okay. Now we have different kind of classical processor. Obviously, the quantum computer are attached to many of the supercomputers as a peripheral, and we can have a neuromorphic. We will have many different processors in a supercomputing center, and obviously we are waiting for the quantum computer to contribute to our task.
How do you respond to that, Loïc?
Yeah, actually, if I want to commit to a timeline where quantum computers are useful for a practical task, I would say in the next 2 years, in the next couple of years. It will be something which will be very specific, of course. It will not be solving like a problem with a huge market potential, but still it will be a very specific thing for which you cannot do it classically, and the only way to do it is with quantum computers. And I really believe that this time is arriving. So you have to really think about the evolution of the technology over the past 10 years. So 10 years ago, we had machines that were operated maybe 1% of the time by very skilled people, like PhDs in physics. And now we have machines that are operating in data centers, in HPC centers. We actually have one machine at Jülich Supercomputing Center that is being commissioned right now.
Yep. And we have also in Barcelona.
Yes, we should have one in Barcelona as well.
Yeah.
And actually, so it's evolving quite fast. I'd say it's the timelines are still reasonable, and over the next couple of years, we'll see a few first applications of quantum computers that are really beyond what classical computers can do. That's our goal at Pascal. I think that's also the timeline of IBM that was announced a couple of weeks ago. Let's see. And yeah, so I'm really excited about how quantum computers can complement AI workflows in one particular area. If I can take one example, it's like if you use a quantum computer to generate data that cannot be generated otherwise, and you train an AI model on top of it. Because using the quantum computers, you really can have like a description of materials, of chemical compounds that is very hard to get otherwise, and you train an AI model onto that to really accelerate materials discovery.
The large-scale synthetic data generation.
Exactly, synthetic data.
Okay.
So I think that the classical supercomputers are waiting really for this technology. 2 years, God bless you. God bless you.
So our activity is to bring them together, to enable this hybrid computing with HPC and quantum computers. And I must really confirm what you said. Your technology, having a quantum simulator, is much closer to application than the gate levels. But you are also approaching the gate level technology.
Yes.
As soon as you have error correction on those systems, things will completely change. We will get a very clear new situation. And then we expect, maybe around 2030, we expect breakthroughs with quantum computing. If this comes, then we have it.
There's room for everybody.
So as Jensen said, just around the corner.
Exactly.
Just around the corner.
So next we'd like to focus on AI in Europe and really hammer on sovereignty and energy. And I'm going to start with sovereignty. So how important is AI sovereignty to the EU? Can you discuss the opportunities and challenges as you see them? First, I'll start with you, Thomas.
So since AI becomes one of the backbones of science, industry, and society, it is important per se, AI as such. Of course, you have to have a sovereign usage and possibility in a democratic country with these technologies. Insofar, one cannot overemphasize how important AI and AI technology and the free usage, of course, under the law and under a democratic law of AI is. Insofar, this question can be easily answered in this direction. So, but of course, we have to get the prerequisites for that, and then we come to the machines.
So
Mateo?
I would say that AI is changing any activity in our world. So the work we do at the supercomputing center has been changing using AI. So no question about that. Concerning the I don't like the word sovereignty. I use autonomy. And I am not happy when we talk about AI and we talk just about software. Okay, in software, I think that in the supercomputing center, we are at the level of any other supercomputing center. In fact, we have collaboration as in with you and many other centers in the trillion of parameter consortium. So we are developing LLMs with much more data than the classical ChatGPT, whatever. But the target for us is to develop AI models helping us to do our work. So at the software level, I don't have any doubt that in the supercomputing center we are at the same level at Argonne, Riken, or whatever. This is not the case for the hardware. If you look, any computer installed in Europe has not European hardware, except the quantum computing. I like the idea of the European Union that we are pushing the quantum computer technology, okay? So we need to change that. We need to change that, okay? And BSc, me in special, has been during the last 15 years trying to animate the people to produce hardware developed in Europe. We were very close with the ARM until SoftBank acquired, and then the Japanese continue our work and produce the Fugaku. And now I think there is a worldwide opportunity based on the RISC-V. So BSc is pushing at the European level the development of any kind of chips from IoT to supercomputer based on RISC-V. So for me, autonomy at the software level, autonomy at the hardware level, and at the technical level, co-design. Because there are so new applications in AI that this is a very good food for us, the computer architect, to design the best chips oriented to execute this AI application.
Shall we move to power?
Yes, move to power and energy. So the power requirements to support supercomputing and maybe AGI, is that incompatible with Europe's focus on climate change and sustainability? And also, isn't Europe at a disadvantage to other regions because of the cost of energy? I mean, maybe, Loïc, do you want to start?
Yeah, well, I will comment on that with really the idea of a quantum computer being integrated in HPC centers in that respect. So I would say that there are, like quantum computers, there are a few technologies that are really opportunities when it comes to power consumption, because they are really low power consumption oriented. So for example, our processors, they can work with a few kilowatts of power, so it's really low. And using that, if you can manage to have to accelerate some parts of a compute workflow, it's really good for that. So frugality is important, I think, in order to really develop the right kinds of processors, and to your point, exactly like specialized computing, so that we really make the most out of the energy that we have. I think it's very important, so that we make things in a responsible way.
Mateo?
Yeah, so this is a classical question. You waste a lot of energy, no? You waste, and it is true. We need a lot of energy in our supercomputing center, but in the other side, we are saving much more energy than we need. Let me give you just one example. In the protein folding project, that has been possible because the AI found the solution much early than the classical simulation, where you know, Thomas, that we waste a lot of energy and we didn't reach until the end, when the protein fall. We are using the supercomputing to get better energy, more productive energy. So we should take anything into account, and not just to say you are wasting a lot of energy. No, we are saving a lot of energy
By solving problems that are important.
Yes, because we solve the problem using less energy than before.
Yeah.
Thomas?
I would say these are very good arguments. There's another one. You have always to use the best processor in terms of energy consumption. And as you know, probably from yesterday's show in Hamburg, the International Supercomputing Conference, again, the NVIDIA system JetDai that we use in Jülich is at number 1 of the green top 500 list. This technology is proven to be the most energy efficient, and you have to start with energy efficiency if you want to minimize that. That's one point. The other one is the technology does not stop, it develops. So technology like GPUs can be based on CMOS. In the future, they might be based on other substrates. Yeah? And in this sense, we hope and we expect that the developments in the next years will go in a direction where energy is minimized. One example would be cryocomputing, digital cryocomputing. We use it for quantum computing, but we can, of course, also use it for digital computing. That's the way to go.
Makes sense. So let's talk about NVIDIA, the partnerships with NVIDIA. That's the reason we're here. So maybe Loïc, start with you, and just how is NVIDIA helping you, and what's the nature of the partnership, and maybe a bit about what you see coming next.
Yeah. So we are working with NVIDIA to actually be able to orchestrate compute workflows across various processors. So we are working in an open source software level with CUDA Quantum to really be able to implement an algorithm that can target both NVIDIA GPUs and Pascal QPUs in a simple way, in a transparent way, so that the user can really leverage the best of both technologies to have like those complex workflows that are working in the most efficient way and easy to code with the software. I think it's a first step. And going forward, there are other places for the quantum computer development where NVIDIA GPUs could be useful. And I'm thinking about quantum error correction, for example. So for quantum error correction, you need really to monitor the quantum computer, to measure and detect for errors and correct them right away. And this is quite a hard task computationally, and you need to do that very fast. And actually integrated GPUs for doing that is a fantastic opportunity. And I think over the next 5 years, it will be one very important development path between quantum computers and NVIDIA GPUs.
Thomas, can you speak to your partnership with NVIDIA?
We have a very long-standing partnership. I think it goes back to 2008 or so, 2009. But in 2012, we have installed an NVIDIA application lab, which was very successful. So lots of our applications have been improved. And this has brought us finally to use NVIDIA technology on a large scale already in 2015. Yeah? Finally giving us the machine Jewels in 2020 and now Jupiter. That's one thing. The other thing, now we start with quantum computing and NVIDIA, including the quantum technology in this lab. And we are looking forward. We think that's a very good step forward.
And Mateo, Barcelona Supercomputer Center.
The same. We start collaborating with NVIDIA more than 15 years ago with Blade. And I think that we were probably the first center predicating the CUDA. We organized many courses to our students. In 2011, we bought a machine with 128 board with NVIDIA. And then in the Marenstrom 4, we have the Power 9 with the Volta, and the Marenstrom 5, we have the Hopper. In the factory, we are going to have the Blackwell. So a long collaboration. And now we collaborate in different topics. For example, interconnection network, how you interconnect the node, application, in the climate change, personalized medicine. We are working also in improving the R processor. And finally, I would say that every year during the last 10 years, David Kerr, who was a co-founder of NVIDIA, computer architect, and Professor Welmy, who are teaching every year in Barcelona during 1 week, CUDA and NVIDIA processor, and we are getting around 100 people worldwide. So we are very happy with this collaboration, and I'm very sure that now in the AI factories, we will continue collaborating.
And talking to co-founders of NVIDIA, do you have any Jensen anecdotes you want to share at all?
Yeah.
Many time in the past?
Yeah.
So you first met him 15 years ago, yeah?
More than 15.
Yeah.
I met Jensen called me, come to meet me. It was more than 15. I went to to Silicon Valley, and we were discussing about at that time R, because we were building in Europe a parallel system based on R, and we were using the chip from the Samsung telephone.
Right.
So we have, with Julie and many other centers, we had the software stack waiting for the R processor reaching the performance of the Intel or whatever. SoftBank bought the company, and then the Japanese Fujitsu continue with this in this direction.
So Jensen has talked about doing your life's work in your lifetime. And so we have about a minute and a half left to each of you. If we are here today, 12 months from now, what would you like to have achieved in that time frame? 30 seconds to each of you.
For the next year, you mean? The question was,
If we meet on this set 12 months from now, what would you have liked to have achieved?
2 months.
12 months. And what do you think we'll be talking about in 12 months' time?
Well, what we will have achieved is that we have complemented our Jupyter system, the exascale system, with an inference system. That's what we want to have in 1 year. So this is only a short-term view, of course, 1 year. It's not my lifetime view, just to say that. I believe in the next years we will have to achieve technologies based on GPU ISAs that are much more energy efficient than we have it today, because this is more or less a hindrance for expanding. We have to expand, and this means we have to find new ways. And as I said, cryotechnology is the right one to look really forward for 10, 15 years.
I apologize, but we have to stop there because we've run out of time. Thank you all for joining us. It's really been a treat. So now we turn to the transformation of industry itself. Industrial AI is not just optimizing processes, but redefining what's possible for Europe's factories, supply chains, and workforce. This chapter dives into how AI is revolutionizing European manufacturing, logistics, and supply chains, from the edge to the cloud.
Jensen is designed for autonomous machines. You can now look at images, infer information from it, and take the appropriate action.
We now have the technology to create new 3D virtual worlds or model our physical world in Omniverse.
Science needs supercharged computers.
So please welcome Dr. Roland Busch, President and CEO of Siemens, the global leader in industrial technology shaping the future of smart infrastructure. Welcome. And welcome to Håkan Samuelsson, the President and CEO of Volvo Cars, the pioneering automaker recognized for its commitment to safety, electrification, and innovation. Welcome, Håkan.
Thank you.
And welcome to Dr. Nadia Carlsten, the CEO of DCAI, the Danish Center for AI Innovation, established to run and operate Gefion, Denmark's first AI supercomputer. Welcome, Nadia.
So a question for Roland and Håkan to start. Let's start at a high level. How is AI transforming manufacturing, and how do you both stay ahead in this rapidly evolving landscape?
So how much time do we have? I mean, AI is about to change the industrial space. I mean, industrial is moving not that fast. If you talk about the shop floor, for example, but it's really about to change everything what we do. We talk about, let's say, creating a digital twin of the real world in order to optimize it there and then translate it in the real world. And this will be supercharged by AI, if you talk about simulation, for example. And the combination of this digital twin of data and AI is making really a big difference, the way how you design stuff, how you operate stuff, how you manufacture. And AI is supercharging the whole development, make it faster, make it better. It will transform the way how we work on the shop floor as well.
Håkan?
No, I think it's coming everywhere. I mean, it's a new tool, so I think you shouldn't see it as something totally new that will revolutionize an area. It will be used everywhere in the industry, product development, production. But for our company, mainly we have been involved in autonomous drive and really the vision systems detecting the road ahead of the car on its way to make it automated. That's really where we have been working most with AI.
So Nadia, your company operates Denmark's first AI supercomputer. So can you talk a little bit about some of the early use cases you've seen?
Yeah, so we've seen a diversity of use cases, which is exactly what we wanted. So Gefion as a supercomputer, we're application agnostic. We built a software and hardware stack that really enables customers to do a bunch of things. One of our sweet spots has been healthcare and life sciences. So we've seen a lot of need and use there. And that's everything from drug discovery, but also some of the more industrial side of things. So how to actually productize manufacturing lines and how to make sure that they're scaled in a way that's efficient. We also see a lot of interest in simulation, and that's quantum computing type simulations that are really pushing these supercomputers to the limits, but also simulations in terms of digital twins and simulating factories and business automation.
Makes sense. So we're going to switch to questions about your nature of your partnership with NVIDIA, the reason we're all here, I guess. And so staying with you, Nadia, so Gefion is built on DGX H100s, I believe. And at a high level, and maybe in terms of both hardware and software, can you talk about what you see coming next in terms of your partnership?
Yeah, so the first step was really all about making these resources accessible. So bringing a lot of GPUs to Denmark and building this amazing computer that is also sovereign. So building world-class infrastructure, but doing it in a sovereign way so that customers could use it. Now, the next step of the collaboration with NVIDIA, now that we've launched a computer, we already have customers and we're getting great use cases, is also going beyond the hardware stack and figuring out what in the software stack and in the tooling and the frameworks can we bring to customers so that they can actually keep up with the complexity of the use cases that we're seeing. So in the future, we'll have more GPUs, of course, we'll have new generation GPUs, but it's also about working with NVIDIA to accelerate the outcomes that our customers are seeing with this computer.
So Roland, sticking with the same theme, can you speak to your current partnership with NVIDIA for AI and simulation, and also, perhaps talk about your industrial foundational model partnership with Microsoft?
So, I mean, the partnership with NVIDIA is crossing a lot of different topics. Let me start with the Omniverse. We use Omniverse in order to really boost our digital twin in the photorealistic world. So that what we do, we have technology which builds a physics-based digital twin. But if you really want to see how it looks like, photorealistic as it can get, we can transform these data, put it into Omniverse, and boost it into this photorealistic world. And that means that you can really walk through a line as if it would be videotaped. So that's one area, and that makes it really completely different because you know really how it looks like, how it feels. Makes a big difference. The other one is when we talk about GPUs and AI, we are training algorithms in the cloud. I mean, the grip in the box of a robot and then you want to have this algorithm to run on the edge. So we are bringing out GPUs to the edge, where you can really have then a thinner application, so to speak. It's trained in the cloud and you can run it on the shop floor. So bringing compute closer and closer, doing things like optical inspection, running manufacturing lines, makes a big difference. Programming robots with natural language, which brings me to the foundation model. We talked about an industrial model. So AI comes today with large language models trained on language. On the shop floor industry, you need multimodal data flowing in, and you need to train the models on really the industrial data, property data. That makes the hit rate of a task when you prompt something going up from 60% to over 90, 95. That's what you want to have. When you talk to a robot on the shop floor, and it does every time you prompt the same prompt, does something different, that's not acceptable really on the shop floor. So in order to get it hardened for the industrial applications, we want and develop now industrial hardened models, so to speak, trained on specific data, and that's what we do.
Makes sense. The shop floor is not a place for hallucinations, is it?
Not really, not really. Or he had to put it in a box, but that's what we want to avoid.
Yeah. So Håkan, Volvo has partnered with NVIDIA since 2016 with the Drive platform. So what's next in your partnership with NVIDIA?
Now, I think we will continue, of course, our way towards autonomous drive and safer vehicles. That's, of course, something very close to the core brand Volvo, safer cars, but also offering a unsupervised driving one day, and that's a long way with bigger algorithms, more machine learning, and that's one area where we will work with them. But I think there is also another area where I think we in a company, if you look into, there is a lot of enterprise intelligence that, especially in the white collar area, there are all type of questions from us managers, and then they have to investigate if there was a tool to really which could have access to all information inside the company, lab reports, protocols from meetings. You could have a very powerful tool to really understand what's going on and what has been learned in different areas. Such an area, I think, would be really interesting to talk with NVIDIA about to add, because I think you should find bigger areas of cooperation, not just small boxed areas where we work together.
So I'd like to take a broader view and contemplate AI for all of Europe. And so this is a question to all of you. I'll start with Roland. But in your view, what are Europe's key strengths and unique challenges in driving AI innovation?
So there's no AI strategy without data. I believe that's one of the biggest challenges. And in many cases, data are sitting in silos. They are not shared. We talk really about property data, machine data, operational data. So getting access to this data is super relevant, and this is an advantage of Europe. Europe is very, very OT savvy, so we have a very strong small and medium-sized enterprises, machine builders, car makers, chemical industry. So there's a lot of substance there, but you have to leverage the value of the data in deploying it, number one. Number two is, I do believe that we need also their own cloud capabilities and AI compute capabilities in Europe for many reasons. Latency is one, there are many others. So in order to make that, I think that's a move which is happening now. We talk about 5 gigafactories, AI factories, which Europe is supposed to support and to make it run. So and the last point is, and this is not a technological one, this whole AI is changing also the business models, so how you monetize. Currently, for example, when we talk about a car manufacturer and we are equipping an assembly line, we are selling semantic PLCs, so industrial PCs. In the future, we talk about software-defined automation. That means you have a hardware and a software, so you're selling a software stack. Completely different business model. Our customers have to adapt, we have to adapt. Don't underestimate that change. It is multidimensional also from that perspective. So that's how it looks like, but it's super relevant. As you said before, AI is a tool. It cuts across every industry. Is it manufacturing industry, the healthcare area, drug discovery, it will be in infrastructure, wherever. So therefore, leverage it on a horizontal basis is super relevant, and therefore we need to gear up our infrastructure in Europe as well.
Nadia?
So the strength of the European ecosystem is the fact that there's a lot of big industrial players, everything from logistics to energy, automation, and that means that in a lot of ways, Europe, when they're talking about AI, they're actually focused on things that matter, like building things with AI, optimizing how things perform with AI. So for me, that's the biggest difference from what's happening in Europe, from the conversation that's happening in the US. There's a little bit less emphasis about apps and software, and there's more emphasis about this heavy AI use cases. And one of the criticisms of Europe is sometimes it does feel like it moves really slow, right? And it feels like working in Europe, sometimes it's like the pace of a committee, whereas everybody else globally is running a sprint. But in the case of industrial AI, that actually is a strength, because we're seeing the slow but steady adoption of AI in these factories. They're all adopting AI in production lines, in drug discovery and manufacturing, and so on. And it's good that they're doing it slowly and deliberately and in a responsible way. And I think that will win the day in this case.
Håkan, any thoughts?
I think two areas. First, I think that this is not going to be solved with some kind of industrial policies or plans. I think it's a creativity that has to be released. So One area is, of course, to have creative people having access to data. So, of course, we have to respect the integrity of people, but still access to data is important. It should maybe not be limited. The other is, I think we have a lot of ideas in Europe. But when I talk to startup companies, the difficulty is to get really investors who believe in this idea. And I think Europe should need one financial market. I mean, if you could imagine the United States with 50 different stock exchanges, I don't think we would have any Apples or NVIDIAs or Tesla. So that I think is to really have people who believe and would have the patience also to invest in newcomers. That I think is a problem for Europe.
Let me double click on this regulation thing in Europe. Yep. I mean, we have an AI Act, a Data Act, a Cybersecurity Act. Many of them derive from B2C business and transfer to B2B. Some regulations are overlapping. We have vertical regulations already in place. Now you're rolling in AI regulations. They're even going beyond AI. They're touching even normal software. So I think it's a little bit too much. We have to bring it back to a normal level, which allows us to innovate faster. And that's, for me, a big task of Europe. If you want to leverage AI big time, then we have to deregulate a little bit.
Because exactly what will be invented, we don't know, and that's really the strength of this. Exactly. We should have creative people, should have more freedom and empowerment to work with those ideas.
Yeah. So let's switch gears and talk about Omniverse and digital twins for a second. So Roland, how is Siemens leveraging NVIDIA's AI and simulation platforms, particularly Omniverse?
So I'm later on stage and will share some examples and give me maybe two of them. One is we're working with HD Hyundai, which is one of the largest shipbuilding companies in the world. They build now a fuel cell or ammonia-powered ship, so hydrogen or ammonia-powered, 7 million parts. So they're working with our software, and all these parts are brought together with Teamcenter, with our data platform, and NX, which is our MCUT and ECUT system. We are simulating everything, so we can simulate any kind of movement when you shake it, when you run power on it. But then what you really want before you release your design, you really want to see how does it really look like? Is everything in place? Can people walk around? We even simulate people running there on the deck. But if you do that, then we bring it into Omniverse, we boost it into the photorealistic world, put it on water, put it on a shipyard with cranes alike, and then you can really see is that design that what you really want. When we built a new manufacturing site at Siemens, we built it twice. We built it first in the digital world. We really render it and then bring it to the photorealistic world with Omniverse and then optimize it. So in one case, we found out that there was a duct somewhere which just didn't matter. So we changed it. So that means you get it first time right. You are much faster. When you build it then in the real world, you have higher space productivity, energy efficiency. And then when you keep your digital twin alive, you can really optimize it. You can break up a line, put a new robot on the shop floor, test it. And then when you make it, when you optimized it in the digital world and you bring it to the real world, you stop the line maybe for a day instead of a week. So this is all about productivity and really changing the way how you work. And this is where Omniverse helps super, because at the end of the day, you really want to see how it really looks like and would it really work at the end of the day.
So Håkan, a similar question, but I'd like to bring in sustainability. The powerful tools you champion, from digital twins to AI models, are resource intensive. So how do you ensure that the sustainability benefits of these solutions decisively outweigh their own environmental costs across the entire life cycle?
Yeah, that's very important. I think for us it's really coming out with really attractive cars and to be able to do that faster and bring them out ready with the quality customer expect. And then of course we have physical testing which is very capital intense and also a bottleneck from a time point of view. I can give you one example. As we have one huge wind tunnel where you want to test a lot of different alternatives with or without the mirrors and so on to really optimize the wind resistance, which is energy consumption. And there is very difficult to just simulate conventional, because we have a lot of references from testing, real-time testing in the wind tunnel. So we really have developed then a digital twin of exactly our wind tunnel, where you then can simulate with and really compare with the real testing in the wind tunnel, because that's what you want to do. And then of course we save a lot of resources and doing this digital. So I think that's a good example for digital twin and also faster development.
Yeah, Nadia, we're working on suppressing these wind tunnels. You can simulate it.
Cool. So Nadia, your Gefion supercomputer is ideal for simulation. So I'm just wondering what you envisage Danish researchers using it for, maybe in combination with NVIDIA Omniverse.
Yeah, so that's been a nice shift for us to see. We've only launched last October and started getting customers early this year. And even in that time frame, we've seen the shift in interest in simulation from just AI training. We have customers that are doing both. And the interesting thing is they've realized that even with our SuperPod that we have now, with the same hardware, they can do training and do some of these simulations. So that's been a really interesting thing for them, that a large pharma company, for example, can use the same system to do model training on genomics data or other drug discovery data, but then also use the system to think about productizing their drug discovery and figuring out the best way to manufacture their drugs. So that's definitely been one of the values. One of the interesting things about Denmark is we have a lot of big industrial companies in logistics and energy production as well. And so for companies like Maersk and Vestas, for example, doing simulations and digital twins, the kind that Roland, you were talking about, that you're doing at Siemens, that's not a nice to have, that's a must have. They have to do these digital twins. They have to have these environments where they can train and test in real world environments and do that in a way that is sovereign. So that's a big thing for us, is that we're a sovereign system. So we're providing these sandboxes for them to test real world constraints, but do it in a way that they can still use their data in a way that feels very safe to them. So we see these workloads happening more and more, and of course there's a lot of interest in bringing Omniverse and Gefion together, because both of them have shown the power of doing complex simulation.
Makes sense. Maybe we should switch to productivity briefly. We've got a few minutes left. Roland, you talked about labor arbitrage before and being transformed, and next productivity leap requiring combination of AI with digital world. So can you talk a bit about that and how you see it?
Yeah, so there's the good news and the bad news in it. Mm-hmm. So the bad news is most of the countries in the northern hemispheres are aging societies. You have less and less labor on the market. For example, the Chinese labor market peaked a couple of years ago. Try to find labor in the United States, not talking about trained labor. So therefore, and I'm always saying the operating model of the world broke, because it was meant to labor arbitrage, bring everything, manufacture in low-cost places. COVID told us that this is not really resilient, so you want to bring it to other places. And that means labor arbitrage is for two aspects gone: resilience and aging societies. So what's the consequence? The consequence, if you want to maintain your productivity, you have to compensate labor by technology. And this is where I believe AI comes into place, but also any kind of digitalization and high level of automation. You will see much more humanoids, robots on the shop floor. You will see disaggregated lines which are working with HEVs. You will have be able with large language models to talk to your robot and train it with your natural language. So even a semi-trained person who cannot program at all can use a robot and work with it. So this level of automation will increase as we speak. It's mandatory to keep the productivity level on a higher level. And that's what I believe is the biggest change, which, by the way, will be supercharged and accelerated with AI technology.
So Håkan, AI is obviously very important to the Volvo business model. Investors are very focused on return on invested capital. So how do you think about the return on investments that you're making in AI?
Probably very difficult to measure exactly if it comes from AI or not, but I mean the power of product development and having really the focus on the top line and the price of the car totally related to how attractive they are. I mean, that is really key. And of course, productivity is also very important, but AI helping us developing the right products, the right cars, that is, I think, helping the price, the margins of the car, and that's what the investors are really looking into when they study our company.
And Nadia, just real brief, we're running out of time, but how is Denmark at sort of dealing with the challenge of upskilling workforce and closing the skills gap?
Yeah, I mean, that's really key. And actually something Roland said really resonated with us because there's a robotics industry in Denmark. And the way they think about robots is absolutely those robots working with people as opposed to displacing people. And that's really key to also having that upskilling conversation because people have to feel like they're not being threatened by this new industrial AI and that they can actually work alongside us. So how we think about upskilling is you can't just throw a Coursera class at a factory worker and expect that they will know anything about AI that's useful. One of the things that we emphasize is real-world training. And so being able to access real project, real computing infrastructure like Gifyan is really key to make sure that they are enabled to fully partake in the AI revolution. The other thing that we collaborate with universities and academic centers is also about how to lower the barriers, how to make AI a little bit more intuitive for people to use. And this is especially important for people who are already in the workforce. And we don't want to lose these people. The domain expertise that they have is extremely important. And without it, AI is not going to be as good. Right? So the ideal scenario is to be able to make these very automated production lines be as intuitive as using Instagram or something like that, but very easy to adopt. So that's also the second piece that we're emphasizing. It's just ease of use, even of complex systems.
I'm afraid we have to stop there. Roland, Håkan, Nadia, thank you very much for joining us.
Thank you.
Thank you for having us.
For our final chapter, we examine Europe's unique approach to building an AI ecosystem that is sovereign, ethical, and collaborative. Europe's quest to harness AI's power while safeguarding trust, sovereignty, and innovation, building a future where AI serves all Europeans, is both unique and challenging.
So with insights from leaders at Mistral and Hugging Face, we'll see how Europe is leveraging open platforms, federated learning, and regulatory leadership to shape AI for the public good.
In order for us to democratize this capability, we have to make it run literally everywhere. Well, the first question is, where are the world's models?
Your country's digital intelligence is a new infrastructure for you. It belongs to you.
And joining us for our final conversation of the morning is Timothée Lacroix, co-founder and chief technology officer of Mistral AI.
Hi, good morning.
And the co-founder of Hugging Face, Thomas Wolf, who also serves as the company's chief science officer. Welcome.
Hi.
So Timothée, to start, Mistral's AI mission is to build world-class AI that's transparent, high-performing, and European at its core. How does that manifest itself day to day?
So I think the most easy way to see our transparency engagements is through open source. We continuously release high-performing open source models. Most recently, yesterday, we released our first reasoning model, Magistral. Last month, we released Devstral, which is an open source coding agent model. And so through this, and every model that we develop, for each of them, there is an open source version that we want to release to the community. In terms of how we work with enterprise, this transparency is most visible through how customizable and customizable our stack is. So every component can be modified and chosen along with basically everything the open source stack offers.
And Tom, so Hugging Face is a champion of obviously open and accessible AI, but in terms of being in Europe and an AI business in Europe, can you talk about some of the challenges and opportunities that demonstrates being in Europe specifically?
So I would say we are not only in Europe, right? We're worldwide, we're a US-based company, but we do have a strong European background. The three co-founders are all French. Our biggest office at the moment is in Paris, just a couple of blocks away. I think for us it means many things. It means, first, for many people, I think Mistral is also a great example. It means access to great people, extremely technical, great engineers. For us it means also, I think there is a huge market in Europe now, and that's what you see, which is around all the things you can do with AI. Basically, all the apps you can build on top of Mistral model, on top of all the models that we provide on Hugging Face. And I think this is where we see the most exciting teams out of Europe, basically taking these models and building extremely interesting app. Take one example. I was playing with my son this weekend. Is Lovable, which lets you vibe code entire website, right? So you can see this team appearing in Europe because basically most of these models are actually open source, so they're very easy to use. You can actually deploy them locally. That's where it's actually really great to have GPUs, NVIDIA, and basically your own data center that are located here. So I think all this idea that you can take this model, have them run in Europe, build amazing app on top of this that are used both in Europe but also worldwide, I think it's very European.
I'm sure some of those amazing European AI engineers and data scientists are coming in right behind us now. So we've touched on open source already, but we're going to touch on it again so many times. So maybe Timothée, then Tom. So there's obviously a debate between open and closed source AI development and the benefits of each. But what do you have is the strongest argument? Obviously, you're going to argue for the open source approach, I assume. But what's the strongest argument for that? And how does a rich ecosystem of hardware and software tools like what NVIDIA offers empower the open community?
So the question of open source was at the core of why we built Mistral. The first model, the first transformer that we trained with Guillaume that had some success was Llama, that we also fought to get open sourced. And what we were frustrated with at the time was that there was amazing progress in the community by big tech on creating these amazing artifacts which require a tremendous amount of GPU power, and no one in the academia has access to these kind of resources. If you provide the model, like the base model that has been trained for a long time, then you empower an entire generation of researchers to actually do the same work and work on top of you. And so this is really how we want to foster that ecosystem. What I really hadn't expected at the time was the amazing work of software on top. Like all of the local deployment, all of that work helped by Hugging Face by a large amount, who's really simplified the code bases to do this. And so all of this, what was missing was the model part that requires a lot of expertise and computational power. Now with the open source software stack that allows you to run everything simply on NVIDIA hardware, it's just easy for everyone to participate in this great technology.
Tom, any thoughts on that?
Yeah, I think right now we're at a great moment in time where open source and closed source, I think both are coexisting in various places, and they're both interesting in various aspects. I think it's important to remember that it was not always the case, right? So you talk about Llama 1, that was one of the most impressive open source releases. And even before, I remember in 2021, that's basically where we started to really grow Hugging Face. We started a couple of projects with some people who are now working at Mistral, right? So Teven, Lucille, all of them. We were very worried at that time because basically for the first time OpenAI had decided not to open source GPT-3 and say we won't do that. And you had really a line of startups appearing, Cohere, AI21, Aleph Alpha. None of these startups were planning to open source any model. So there was a time 3-4 years ago that the future was really looking closed source. It was all about private models. All of these models basically retraining exactly the same model in parallel because there's no mutualization of efforts in closed source, right? So everyone has to train their own frontier model because they don't share. So at that time, we started a project called Bloom, which was basically our first GPT-1 learning on how to train an open source model. And the fact that we decided to really say, this is going to be an open model, we're going to make a lot of mistakes, we're going to learn how to train this model and bring many people together, kind of push, in a way, Meta to open source OPT. That was maybe the first large model that was open source. And like, in a way, Bootstrap decided that open source could be something for model. I think this has grown progressively. And probably at the beginning of this year, there was what I call the ChatGPT moment for open source, which was basically DeepSeek coming out. And even people who didn't know about AI, and open source AI is still kind of a subfield of AI. So you need to first know AI to learn open source. But these people, we started to have people like my parents saying, what is open source? I read about this DeepSeek thing. What is this thing? And I think it's a very good sign because it means people just get used to this. We always have these two things. I think having like frontier model that are closed source make a lot of sense, but having all this range of open source model that you can customize, you can put on device, you don't have to always call this data center somewhere in the US or far. You can run a lot of this model actually locally. I think this is also something that's going to be increasingly super valuable.
Yeah, it's not a zero-sum game, is it? It's not all or nothing. Like it's all open source or it's all closed. It's going to be a mix.
Just like in operating software, we have open source. We also have closed source software. They both have different interest benefits. They both coexist. I think it's going to be the same in AI.
Yep.
Well, sticking with the same theme, and I think we have a great perspective from having you both here, looking at the the full developer journey from model creation to deployment. What's the single biggest friction point that you're working on today? Start with you, Tom, and then we'll move to Timothée.
The friction point in software, well, there are so many. I mean, we were talking about that just before entering on stage. I think one friction point right now I see is, I mean, the stack is constantly improving. The easy access to this model, how easy it is to develop them. There's still a lot of things we could do better. There's a lot of these systems that are still kind of, in a way, they are legacy from the traditional stack of software, which is more based on CPU and type of thing, that are not really moved yet to this AI, which is based on batching, trying to group requests, trying to have this very efficient. So there is a lot of software thing that you can improve. For me, I think the biggest thing and the one where we try to be the most active is around education. We think people should learn how to use these tools, should learn how to develop with them. Every software developer nowadays, I think there's like a little bit more than 100 million or quite more right now, software developers, they will all become AI developers. So they need to know not only how to use these tools, but in my opinion, I think you would agree, also how to train them in a way, how they work, right, deeply. So I think education is something we focus a lot at Hugging Face. We had a lot of classes recently also on agents, how to train now reasoning model. But I'll let you add maybe what.
Sure. In terms of the software stack, it's impressive what people have built. And in particular, I must commend PyTorch for being such an integral part of that ecosystem. It's a pleasure to work with. The biggest friction point I see is in moving to prod. So taking that proof of concept of, okay, this thing might work, to actually getting it to work in an enterprise environment or for a use case, and doing this with confidence. I don't think any of the tools out there are really good enough for this. And one of the benefits of the open source ecosystem is that you get everyone to participate. One of the issues that you find is that you also have so many options. Until things crystallize in a way and there is a known good way to do things, it's pretty much a free-for-all of, well, I've got tens of options, what do I do? And so education is an important part of fixing this. And honestly, it's also difficult because no one knows precisely what the right way is. Like, there is no set process into how we take a proof of concept and go to prod. This technology is 2 years old. And so I think one of the biggest friction points that I try to address is, okay, what is the process that we at Mistral want to see? How do we make it successful within Mistral, and how do we empower all of our users to also use that process easily, safely, and mainly confidently?
You hear a lot about the percentage of workloads that don't make it to production with 30, 50, 70%, but it's good to hear that there's something you can actually do about this, which is good. So let's just switch gears and talk about NVIDIA. The reason we're here in particular, maybe Timothée, just starting again with you. So NVIDIA obviously underpins a lot of issues, but how does Mistral leverage NVIDIA GPUs and services to train your models efficiently?
All of our training infrastructure runs on NVIDIA. Right. We started Mistral as a company wanting to train models, and we were eager to train them quickly. NVIDIA and the PyTorch ecosystem was what we knew and what we wanted to use. And so there was no question of using anything else. We wanted to focus on what we knew worked. And so we went with NVIDIA, and that choice of not trying to change or test new technology and use something that works just allowed us to be known worldwide for our speed.
Similar question to you, Thomas. What role is NVIDIA playing in helping Hugging Face advance open source AI across European research and industry?
Yeah, sure. So our view is slightly different, I would say, because we're this huge platform where people can find great models. So we mostly want two things. We want to have great models on the platform, and then we want people to use them easily. And I think on both sides, NVIDIA is really helping us, and it's been great partnership. We've been working with NVIDIA for many years, both on providing great models. Even recently, there is a big shift to robotics. There was an amazing growth world model by NVIDIA that can power robots. I think this is really great. I think the fact that we can bring this kind of kind of a general model on the platform that people can then download and use in their robots is very exciting. And then the second part is obviously you want to use this model, either fine-tune them or run them. And then we have this partnership around DGX Cloud, how you can, and this is something we're going to expand more. And we are very excited about that, which is basically a very easy way to kind of fine-tune and train this model. And then obviously how to run them. And that's also a part of partnership with Triton and with Triton. And then basically how you can deploy and try to run on the local compute, which is most case GPU, personal GPU, or like at a small data center scale. How you can run that efficiently? That's really an ongoing partnership. We've been working on that together for many years. I think probably a bit more than 3 years now. Yeah.
I just want to switch gears to edge AI and inference, if I may. So Timothée, when designing a new model, how much do you specifically think about and architect it for edge versus data center or cloud, or what are the kind of trade-offs you need to make in that?
It's mainly a question of size of model. When we train a new model architecture, we think about what sizes are going to be most useful. So we want the performances to be good enough that the model is useful, but the size to fit. For example, our 24 billion parameter suite is really well adapted to local deployment and, for example, on laptops or devices like this. We think about what use cases are going to be enabled by that size of model, and so we really focus on finding the right size for the right use cases. And we don't really adapt the architecture per se. It's really a scaling of the number of parameters and the number of layers for each use case.
Makes sense. So maybe we move to the future of AI. So Thomas, robotics is an area of growing interest. How is Hugging Face leveraging NVIDIA's hardware and software stack to accelerate open source robotics research and development?
A lot. The same again, both on training and inference. You want to train, just like Timothée was saying, we want to train this model as slightly smaller because they will run in a robots. I think the first thing is you want to run them locally. I think that's the first thing to get for robots. You cannot really rely on connection for key thing. If your robots lose connection and keep walking in the crowd, and it's going to be really like a security. We talk about safety in LLM, but this is next level safety, right? It's like a physical safety. So you want to have this model optimized to run on the edge, and then you want to be able to run them on small compute. But the thing is, you still need something that's fairly decent, right? So that's where basically things like Jensen are basically perfectly adapted to run this model locally on the robots. And the second thing associated to that is to train the model that kind of fit well in these form factors. I think it's very positive development of the recent years, which is we can train small models better and better, I think. We know better and better how to train these models in the 3 to 24, maybe 24 is 24 billion parameters. It's a little bit large for robots, but it will be soon. But all we see in the robotic world, the VLM around 3 billion, is now getting really at the level where it can be reliable, and there is like clear path, in my opinion, I may be slightly optimistic, but there is a clear path to production, to basically having these robots actually do useful tasks in the world.
Yeah, makes sense. And so Timothée, similarly, different, not robotics necessarily, but looking through the breakthroughs in AI, what do you expect to come from open models, open architects, open collaborations, those kinds of things?
I'd like a lot more collaboration with academia. What I'm really excited about is the work that we're doing with enterprise, how that will then potentially propagate. I mean, I see like everyone is struggling to put AI in prod, as I've said. Hopefully the path to achieve this, or verticalized artifacts will potentially make it to the open source world as well. And it's really important to me that, as you said, efforts are not repeated in silos everywhere around the globe, because that's not sustainable in my opinion. And so really expanding the horizon of what's open sourced is really crucial in my opinion.
So you're talking about the open source, the development of models that apply to different industries, specifically, because AI gets very vertical specific, very
exactly
very quickly.
This, or even like deep success stories of real life workflows or automation, because everyone today is speaking about agents, but I struggle to find a good large example of complex workflows that have been solved today, and so I think this sort of blueprint is also essential to share with the world.
Yeah, trust me, I spend my time watching this stuff, and there isn't a great example yet. So it's very early days, very early days.
I'd love to move to the challenges of scaling an AI company and industry in Europe. So maybe Thomas, can you speak to sourcing AI talent and perhaps what EU countries need to do to foster a robust AI industry?
Yeah, I'm quite optimistic. I think really Hugging Face has had this trend where most of our workforce was originally in the US, and we kind of moved to Europe, and not because we wanted to push for any, I don't know, political reason, push the company in this direction, but really attracted by the talent pool that we got there, which was extremely impressive for us. Though, one thing to keep in mind is we're also a remote-first company, which makes it quite easy to just naturally spot talents everywhere. So we basically spot this galaxy of talents quite some time ago, actually. Yeah? Now it's getting increasingly harder to hire in Paris. I think there is like definitely challenging teams who are battling on the same candidates, I think. So what I would expect to see in Europe is basically new hubs being created, right? So Paris, there was originally, I would say London was maybe the first hub, right, around DeepMind. Paris has been in the recent years the coming hub, but last week I was in Stockholm, where you feel like there is also this huge density of talent. Another hub, I think, is Amsterdam. Munich is growing also. There's very good universities. There is like this notion that you can move to industry very easily. So I think we'll have like this number of hubs that are going to grow with huge talent pool, exciting startup. Zurich is another one.
What about the Baltics, do you think, as well? The Baltic states?
Baltics, yeah. It's starting only. I only know Estonia on my side. Lithuania has kind of like Vinted, or there is a couple of success stories. Zurich is for us the strongest growing region in Europe at the moment. Okay. Huge talent pool. And still not too many competitors in terms of hiring.
So Timothée, you're the kind of French flagship of AI, and so but what do you see? Thinking about capital as well, and capital availability and the risk appetite for capital in Europe. I mean, can you talk about what it's like, building companies in Europe?
I mean, we've managed to scale as a European company. I hope we're not seen as French that much, even though we are headquartered in Paris, but our ambitions are definitely European and worldwide. In terms of capital, we've had access. I mean, we've had access to European and American or other capital, so that's not been an issue. I guess the capital in Europe is there, but more fragmented, and so it's more conversations, basically. But yeah, what's really exciting about Europe, as Thomas mentioned, is the talent pool, which is just gigantic.
So that shouldn't hold us. Yeah, there should be no reason to hold us back at all, is it? It's just a question of, I guess, as each talent pool gets more expensive, you move to another one, doesn't it? It's kind of labor arbitrage.
I mean, it's also like in these interviews, I often get the question of what's holding us back. I don't think there's anything holding us back, really. Like,
doesn't seem to be. No.
There are lots of success stories, and like a lot of fantastic people are studying in Europe and want to stay in Europe. A lot of people are in the US wanting to work for European companies. Like, I don't think there is really an issue either around capital or talent. I think we've got a super exciting opportunity to, build something in Europe without really thinking about, well, what's holding us back. I mean, I don't think there is really anything today.
Fair enough.
So I think we have a minute left. So 30 seconds to both of you. If we meet 12 months from today on this set, what do you hope to have accomplished?
12 months from today. I often make this joke, but I'm pretty sure it will happen, which is 12 months from today, when we're going to be here, we'll have robots walking around bringing us coffee.
Okay, we'll hold you to that.
I guess no more questions and issues around workflows not making it to prod, like actual impressive examples of this is the transformation that we've achieved with AI in a large, like 100,000 employee company, and something that we've helped transition.
Well, thank you both for joining. That's our show. What incredible conversations. We've got to run inside for Jensen's keynote. You at home have the best seats in the house. For Nick Patience, I'm CJ Muse. Merci and au revoir. Ciao.